This is the last adding vectors example, adding non-perpendicular vectors example 2. This time no amusing story, I just have to add a whole bunch of vectors. That's going to be 5 meters at 20 degrees, 7 meters at 150 degrees, 20 meters at 40 degrees, and 12 meters at 340 degrees. Now these are interesting because they're not all in the first quadrant anymore. That's okay. I can still break them down into the x and y components the same way. If I am remembering about the sides of my triangle, that this is the x and that this is the y, and I'm trying to get the x and y components, I can remember that cosine of theta equals x over r. So that means x equals r times cosine theta, cosine, and then sine of theta equals y over r. So that means y equals r times sine of theta. So I can start working these into my calculator. 5, and then I said that it's going to be cosine for x. 5 cosine 20 is going to be 4.70, and then 5 times the sine of 20 is going to be 1.71. 7 times the cosine of 150 is going to be negative 6.06. 7 times the sine of 150 is going to be positive 3.5. These are all things you'll need to do with your calculator. It's not like you can do them in your head. 20 cosine 40 is going to be 15.32, and then 20 sine 40 is going to be 12.86. Finally, 12 cosine 340 is going to be 11.28, and then 12 sine 340 is going to be negative 4.10. I add up all my x's and I get my big X. Big X is going to be 25.24. Add up all my y's and get my big Y. That is going to be 13.97. It's my big X and my big Y, so I will go ahead and draw out the triangle that goes along with them. It's 25.24 is my x-axis, and 13.97 is my y-axis. And this is my resultant here. I know I can use the Pythagorean theorem, and don't even have to show that anymore, I don't think. That's 28.85 meters. I still do have to get the angle. And I'd be using the y and the x, and that sounds like the TOA part of SOHCAHTOA. And remember, that's going to be tangent of theta equals the opposite over the adjacent, and it's also written as y over the x. Rearranging, solving just for theta, I have theta equals the arctangent, or tan to the minus 1, of y divided by the x. Now plugging in my actual numbers, tan to the minus 1 of the y, that's 13.97, divided by the x, which is the 25.24, and tap that into my calculator. I have theta is approximately 28.97 6 degrees. So that means my resultant final answer is going to be, just rounding off, that's going to be 29 meters at 29 degrees. Isn't that quite interesting? And checking my numbers, that does seem to work out because 29 is larger than the X or the Y individually, but it is smaller than the two of them added together. Okay, and the whole idea of it being 29 degrees right here, my Y component is smaller than my X component, so that means my angle should be less than 45. You can't really check by looking at these X and Y values right here. You really do have to add them up into the big X and the big Y. No shortcuts there. Physics.